so verrenken so viel.
Okay, so thank you for coming for the first presentation today. Well, good thing we could get up out of the tent, and you're still in here in that fucking heat. So, I've got one other presentation, which is split in 3 parts. The first part is just 3 slides advertisement for our group. So you can see a bit in that part if you want to. Then the big part is about amap, one of our tools about application mapping, which was released about a year ago, and just highlights it so people hopefully start to use it more and more. And the third and final part is about a new tool which we have released just today, which is an alpha state, but it's already usable. And let's start. So first, THC. THC was founded about 8 years ago, where we have tonight a small party with our friends, and if you bring some booze, you can join our party as well. We are across the Cyberpunks, OpenBXD guys tent. So if you bring booze, you can join. 8 years. We were still young back then. We first thought of, okay, we are joining a new group, we must be cool. So we need to acronym first, so we came up with THC, because it was just cool. Later we were thinking, what could it really mean? And then, well, after some thoughts, we came about, it means the hacker's choice. Well, it's still the same today. Mostly a German group, although there's some guys from Vietnam, Netherlands, and some other countries. And most important, we are a release group. So we're not a group which just releasing exploits, hacking the systems or whatever. We are a group of information sharing, publishing information, and writing just to cool tools. Therefore, very important, we don't do illegal stuff. We may write code which enables hackers to do evil things, but that's their business, not ours. We mostly write dual-use tools, so to say. And we are active in almost all areas: network security, Unix, Windows applications, credit cards, war dialing, war driving, phreaking, cryptography, stuff, throwing backdoors, exploits, ethical stuff. We've been active in all areas with releases. Just a small image of what we do. And of course, there's our website where we have lots of tools online, articles, a few exploits, we don't really care about that. We've got a great forum where you can ask questions, and if you're lucky, you might receive an answer, like don't bore us with your shit. And a very cool online quiz, which is with new questions every 2 weeks, with a high score for the quiz, an overall high score, with very cool questions, just like the hacker geography yesterday. Well, just visit us. Don't now service us, because even Microsoft or whatever can be lost. We're just nice guys doing stuff with you. Okay, so let's go over to the first real presentation, which is about amap, an application network. And to show you when to use this tool and what this thing all about, I will show you how, if you're a penetration tester, because we're not hackers, we do business stuff, so we do real penetration tests for customers, of course, and how this tool fits into that process of work. This is the normal task, what you do if you want to do penetration tests. First, you gather general information about the target, like who is information, DNS zone transfers, checking their websites, checking netcraft or whatever. Then you decide on, well, now I'm going to my target to do active information gathering stuff, like service identification. So you check which ports are really open. What operating system type is that? Then you do service information gathering after you know which ports are open. Next step is, of course, checking banners. What is it? Is it SMTP? Is it a web server? Whatever. And then you finally attack the service until you are successful with the break-in. If not, after no ports are left, go to the next target. So, as I said, in the target information gathering data, port scanning, voice identification, and IP settings, like source routing and stuff. The service identification, you've got banner grabbing, and then the identification, what that service really is. With service information gathering, we have something which is called setup exploration. Setup exploration means if there's a web server, you need to know is WebDAV enabled, so you can change web pages just by a web browser with a WebDAV protocol. If it's FTP, is anonymous FTP enabled or not? Is there a writable directories, for example? That's what you do with service information gathering, how that service is set up. And okay, technical is just the one of course. What tools do already exist to support you in that method? Well, the port scanning, of course, you've got amap. I mean, there are some other tools like ScanRent from Packet Package or bscan or some other stuff. But the tool of the trade here is really amap. For the OS identification, there are two tools, it's amap again and Xpro, which helps to really identify the operating system. For the IT settings, again, you've got amap for IP settings stuff. ICP query you can use for if it answers to ICP timestamp request, netmask request, for example. Then you can use netcat, for example, for source routing if the system supports source routing attempts or not. Now let's go down. For the exploits attempts, of course, what there are many exploits downloadable by hack.co.za or security focus or wherever you want to download it from Tiso guys. For the service information gathering, how is the service set up? Many exist, some, for example, for web or for FTP, something like Babel Web, for example, which checks how a web service is set up, which CGI scripts are located where, which email addresses are there, what comments are in the HTML code, all that stuff. Some of these tools are there, but they're always service specific. And for the middle box, which is very important because as you see, there is a hardware really decide what type of service this is and if it can attack it or not. There, for banner grabbing, you've got TCC scan, which is part of the statement package. You've got grab, I think it's a Tiso tool, network, and a few others, which just do general banner grabbing. But for the identification stuff, there was back then no tool for that. Well, this has changed. Now there is a patch for amap, which in addition, there's no part of a normal patch which does the same like our tool, but ours is of course better. No question about that. And it's called amap, application mapper. Well, the common problems with identification of applications, so you've got some port, we found a port open, it's port 5000 for example. You don't know what's running there. You do a banner grab and maybe it reports nothing back. So no idea what's running there. And there are so many protocols in this VNC. It might be some proprietary stuff. It might be a hacked root shell bind to that port. It might be telnet FTP. It could be anything. You just don't know. Well, if you banner grab, if it has a banner, it's pretty easy to identify the protocol. If it's plain text. If it's not plain text, you've got a problem. Many protocols just answer if you send the right initialization string. If you don't send the right initialization string, it just drops the connection and just silent. So you never know what this really is. And of course, those trigger strings are different for all different protocols. So, if there's SAP-R3 or Oracle installation TNS list or whatever on an unusual port, it will just not identify that. Well, I don't know. Because this is how amap works. There are two important files in the package, which is the trigger and the response file. The trigger file contains all documented responses for known protocols. For example, for the TNS particle TNS listener, for SFPR3, also for some other stuff, RPC stuff, DNS. So all the triggers which are unique for a protocol, which it needs to trigger a response, these are put in the trigger file. Then there's a response file. In the response file, you've got all the response, how the system reacts to your input, and maps that to the protocol name. So it's pretty easy and straightforward. So it's not very deep technical presentation, as you can already see, because it's pretty straightforward, but it takes a long time to collect all that information and stuff. So it also does RPC identification. So really you can say this RPC port is NFS in version 3. It also does that. So what does it do? It allows you to go ports in parallel and hosts in parallel. And it does it in an intelligent way to prevent that sockets are spawned too fast. So too fast respawns and ports are disabled. Also for speed increase. It currently has about 25 triggers. There are some triggers that are just for TCP protocols, some triggers are just for Unity protocols, and a few are for both protocols. It has about 250 response IDs, which maps to about 180 different protocols, so really, really much. And 450 RPC identifications. So even if you have some weird IRIX station with some weird RPC daemon running there, good chance that you will identify it. But kudos is for that is not anyone from us, this is just from the AMAP. It can even identify services that have an SSL front end. For example, you've got an FTP service, and in front of that, for whatever reason, you decide to put an SSL front end with SCOW, SSL proxy, or whatever. It first identifies this is SSL, what is running in front of that, and then reconnects, and now checks, okay, what's running behind this SSL service, and will then detect, okay, it's Telnet or it's FTP or whatever. And it can identify the exact RPC type. And it's so intelligent that even if you're very, very weird, you have an NFS mount daemon running on port 6000 with SSL front end. It will tell you that. And of course, very important, it can use AMAP port scan output files. So first you just port scan, have all in output file, then you just read that in AMAP, and like, there are your services. So it's pretty straightforward and not much thinking you have to do. It's just good kitty stuff now. That's what we're all about, right? Yeah. Of course, machine readable output files, blah, 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 blah. There's another tool included, which is called AMAP CRAP, which is for, let's say you've got a proprietary port count on some system, and it just gives no answer to no triggers, whatever. There is now AMAP CRAP, which you just run against that port, and it sends random information. It sends random information, disconnects, connects again, it sends random information, disconnects, connects again, all the way until it gets a response. And it gets a response from the systems finally. It brings a response depends on what trigger was sent to initiate that response. So you've got also the tool, if you don't know anything about that protocol, it enables you maybe 5 years if it needs that time for running to help you to identify a protocol finally. And also, but that's a side product by them, so to say, it enables you to do buffer overflow scans. Because you also, if the port is closed after sending the data and you can't connect anymore, it says, okay, here was probably buffer overflow identified. It reports to that. Okay, AMAP has tons of options. Just you're very impressed by that slide. Well, good. Let's come to the next slide. This is how the output looks like. There are many different output modes. This is the verbose output mode, which shows you which trigger, the trigger type you see by trigger HTTP or by trigger FTP, by trigger MSPS, which trigger result in which identification output response. These are, by the way, just stuff I made yesterday. So I just scanned some systems here from the CampNet. So it's real live data, well, not live, but 1 day old. So first you can see that it identified edge bias session time, SSH, open SSH, LPD stuff. And here the RPC identification phase also told us there's an RPC NFS version 3 running and an nlock manager version 4. This is the format of that script file, which I won't bore you with the details. It's just for completeness because you will be able to download the presentation as a PDF file, so you have the information there. I won't bore you with the details. If you're interested on how the formula file is, you can just read it up. Same for the response file. The only thing which is interesting, it's really intelligent. So it's not just this is the protocol name and this is the response. You can have dependencies, right? This is a true match if it was triggered by that trigger ID, or if it's TCP or UDP protocol, or if it's minimum that length, a maximum of that length of data. Statistics. How long does it really need to identify a service? For one port, it's approximately 1 second. And if you do the fast mode, -1, which means just take the first identification of the port, don't check if it could be identified with several triggers into several protocols. Just if it answers to one protocol, it's fine, don't ask any further. It's of course much faster as it needs to send much less triggers to get much less connection to the target. Then you need approximately 1/10 of a second per service. Plus the program startup, waiting for finishing of connections. All in all, if you get the system which is 20 ports open, in normal mode it needs about 25 seconds to complete. So speed is fine. So what are the important options? As we saw, there were many options. These are the important ones. For the script, please just note these one. -B is to print the banners, which is of course always mandatory, because also amap can do things wrong, misidentify, and banner also might tell you which is not only this FTP, it's the always Washington University FTP in version 2.4.2, whatever. -1 is if you want really speed, because there are intelligent triggers in there. For example, if you have an DNS server identified, it tells you if it's a byte 8, a byte 9, if it's a Microsoft byte, or if there are some other types of byte DNS servers which can be identified. So it's not only plain this is FTP, this is SMTP, but for some protocols we even identify what product it really is. For example, we did it for DNS, and we did it for SSH and for HTTP. So if it's Tomcat or IIS or Apache or whatever. Then -MO, M is for machine readable output, -O file is generated output file, of course. It's something which you should always do. And if amap receives an identification from a system which is not in its database, it prints this message, unrecognized response from receive, send this output and the name of the application to amap-lab@phd.org, and then the output which was received. So if you find something like that, please send it to us. You can add it to the database, and the next release is even more complete than the one before. And again, down there, the email where you can reach the developers. The tool which was developed by EJ Raccoon. I already told a bit about amap-prep, which is a tool to brute force protocol initiation strings. And not that much options, as these are really not really needed. The one which you usually need is you just need -NB, which is that you just send binary data. You have the option of just sending special numbers of load strings or special numbers of ASCII strings, so just big letters, small letters, spaces, numbers, and some other things. So this is what you usually do, minus NB, that's it. And if it succeeds, it tells you if the service crashed, it also tells you that. This is how it would look like. It brings the output is made in a way that you can just copy and paste it into the app.trick file. So no need to put your brain into that. No, just copy paste. We try to make it very simple for you. And now that you have the tool, what is a script kiddie script to use it? Just copy paste. That's what you can do for an attack script, where you can make your homemade nesses or whatever. Amap, target, amap, the output of that scan, and then identification of the protocol. If MySQL was, for example, identified on whatever port, doesn't matter. The MySQL exploit is already then sent to that port it was identified on, so even if it's an unusual one. It's something Nessus partially does do already, but only on very few services. Well, this is why we hope that amap is included into Nessus and other stuff soon. So, conclusions. So, amap makes protocol identification very, very easy. Well, script kiddie like. Why is that important? If you have 50 ports open, or you scan internal networks with maybe 6,000 ports open, if you do that all by hand or you rely on just random grabbing, will be many false positives. You won't identify many protocols, so this can really help you to speed up the process and raise the overall quality of the penetration testing. Still, if you want to identify some protocols, it's hard. Some stuff needs dynamic data sent to them. For example, if you would like to be able to identify TFTP, it doesn't work because you have to send the TFTP package on which local UDP port you are listening for the reply. So the answer is sent to a different port. And that would have to be dynamic. You might put something in like that in the future, but stuff like that is currently not possible, but there are just very few protocols. Well, the more binary protocols are out there will be more and more and more. The whole process will take longer and longer as one trigger will have to be sent to all open ports. So if you have 5,000 open ports, one additional trigger ID you put into the database means 5,000 extra connections. So overall it will take longer and longer and longer. And there are a few protocols which can't be identified by the output. Stuff which, for example, like time being port 1 to 123, we have an identification for that in, which is valid for the next 5-6 years, and it's somehow dynamic, it's not that easy. Oh yeah, and we have a mailing list for those who want to support, for those who want to be beta testers, for those who just want to communicate about amap, make proposals what should be in there as new features, whatever. Just send an email to amap@subscribe@tc.org, and we occasionally send beta versions to that list. And then maybe 1 month later we make it public or something. So if you really want to stay on track with the newest versions, subscribe. Otherwise, just wait until you have a stable version with less bugs, but still with stuff. So what is the future? We will add more and more protocol identifications, of course. We hope to get it added into Nessus. Hydra, some other tool is already into Nessus, so we hope to get that in as well. And what it states that we're not thinking of there are important features missing. Well, there are some, for example, we have an XML database in the background which checks when things change. So there's something we're thinking that would be a pretty cool feature, but give us your input. If you think that might be cool, it would be really useful and added value to such a tool. Just write us an email. And you can get it from our website. We just released it 20 minutes ago. So a really fresh download. Nearly 0 day winners. So, any questions for that part of the presentation? Was it too broad or too technical? Not more for the teaser guy who just want to tease me. Oh, you fell asleep, okay. Okay, if there are no questions, I move on to the next part of the presentation. Sorry?
Not really a question, but what I thought we out of the is that finished with two ends, one end.
Okay. Just tell me afterwards because I already forgot where it might be the type of it. Tell me afterwards and I'll fix that. It will be that. Download 4.3 if you really want the type of it to be removed. Okay, so the final presentation. Another question?
Why is it hard to identify time D?
Time D is, it just responds with 4 bytes, and the 4 bytes is the epoch, or it's called on Unix. And of course, there are just 4 bytes which says this is the number of seconds since 1970 January 1. And of course, you've got 4 bytes which just change constantly. Every second, 1 byte is increased by 1. So the only real identification would be it has to be past the size of 4 bytes. So what we do to have a better identification, say the first 2 bytes are fixed for the next 10 years. So we put, say, length of 4. First 2 bytes are this, and that's our identification. You might always think, okay, we just take the current time, but then the time on the target system might be completely different. It might be because it's a different time zone. It might be because it's just reboot system BIOS is out of order, whatever.
The output is 4 bytes. You revert it.
Yeah, but still you don't. You might never know if it's just if the target system might have just the wrong time. You can never be sure. That's why we take that approach. That's why some protocols are harder to identify, but we still try. Yes, it's good.
Do you read out timestamps, compile timestamps from like WUFTP or PIDP to identify, for example, this is the Debian Slick distribution or whatever?
This is not part of amap. This is part of a very new release. Thank you for that support. For a tool which is from Viking, our new THC member, which will be released tomorrow, which does exactly that. For example, if you have some administrator and he try to be intelligent, and he changed the banner, for example, for FTP, so it was Washington University FTP, and now it says go away. This tool will fingerprint that application and report it as Washington University FTP. That's why I call it VMAP, version map. Will be released tomorrow, or maybe in the evening, depending on the amount of beer we will consume this evening. Who knows? That's what we put in there. Otherwise, we have same functionality in 2 tools. We want people to use all our tools, not just one. Oh yeah. This is my company laptop, where every time at 12:30 the virus scanner starts. I have that on. So, if there are any more questions, please come afterwards to me. I'm open for all your questions. The final presentation is about Grand Scanner. A tool we have just released 20 minutes ago, was unreleased before, and put that up in front. It's still in alpha state. So in some occasions it still might crash. But still, it won't hurt your systems. So, imagine the following. You own a server on a network somewhere. This server, however, is protected by a firewall, and it just allows a few port in. So, for example, there was port 80 open through that firewall, and you penetrated that system by buggy IIS, whatever web server type there. So you can execute commands in the system. Whoever your tools on the train would like to use, for example, some cool exploit, they don't compile the system. It might not have a compiler installed. You might not have an interactive login, whatever. But you would like to use that box for your further hacking, well, what can you do to actually use that system for your purpose? Even that it's mostly protected by a firewall, you can't just tell it, interact or interactive stuff, whatever. What tools exist to help you in that position? So this is just a small example how it might look like. This is you over the internet, and you've got some firewall stuff with a DNS, an internal network behind the firewall, with an internal web server, whatever. So this is just an example where we come to later. You might have penetrated that web server in the DNS area, which is a Solaris machine. You might even, through some reverse proxy, buggy stuff, even have access to that internal web server. So what tools do support you and to misuse that machine to put your to use your tools on that internal network card, which should be protected. First, with the web server, there are some stuff like command ASP, there are stuff for Unix web servers, which enables you to just execute local commands on the system. There's also telnet stuff, where you can do telnet via an ASP script from the Windows server. There are some reverse shells like our www.shell.pl for a reverse web shell, which can work over proxies. It looks like HTTP protocol. You can do netcat, just netcat, which executes local bin.h or command.com or whatever, command exe, and it connects back to you. There are some exploits which do that. Then there's HTTP tunnel, which helps you to tunnel single connections, so everything which is sent to the local port 25 is tunneled via HTTP protocol through a firewall somewhere out there on the internet. And if you want to tunnel multiple connections, you can, of course, do IPsec, SOCs, or this is a new tool, Grenslinger. When we have a look for the multiple connection stuff, what does that mean? If you would like to do IPsec, you need an IPsec implementation which works over a special TCP port. Otherwise, you will not get it through any firewall. And you need to install that VPN client or server software or whatever on that internal system, which might be administrator or root rights. And then still might be detectable. But if these conditions are met, the IPsec stuff is the best solution you can go for. Even better than Grenslinger or whatever. Then there is SOCs. Who in that room does not know what SOCs is? Then I shouldn't care about telling you, it's just one. Well, I will explain it later when I go to Grenslinger, what Grenslinger is. Grenslinger is something which you can use on your local system to execute commands which perform the actions on the target network. It does this by using a preloaded library on your local Linux system. It also is confirmed to work on Solaris. You need a small patch, which will be in the next release. It will then also work on OpenBSD and other BSD types. But currently it's a Linux release, but it will soon change. It hooks into the following library calls: connect, get host by name, get host by address, and a few others which are not so important at that moment. Any usual connect call to something is hijacked, intercepted, routed through several tunnels, and then executed on the last tunnel. So, for example, if you want to do a telnet on a port, which is behind several firewalls where you have installed your proxies, you tell the Grenslinger to load the Grenslinger library, use your telnet, and the telnet transparently goes through all your proxies and then goes to the final telnet port, which would have been protected by the firewalls in between. So this is the basic it really does. You also can do DNS, reverse mapping stuff with that, but it's just some added thing. It is pretty similar to SOCs because it's the same thing how SOCs work. SOCs is also some transparent firewalling software really, which allows you to transport whatever TCP UDP protocols over some, well, transport proxy. Granscaler is the same, but removes all that stuff for authentication and stuff we don't really care. And in the next release, will therefore implement full encryption of all data, which is important, of course. So, in essence, Granscaler is a hacked source for us. What does not work with Granscaler? You can't use raw sockets because you hook up into the connect call. If you something use raw sockets like Ender with a SYN scan, FIN scan, extract scan, minus scan, or whatever type of scan, it does not work because it's raw sockets. And why does it not work? Because it sniffs the replies from the wire. So if there's a SYN ACK from a SYN scan, it watches the socket, so it drops on the line and sees what replies come back. And that's not possible if you use such a proxy in between, because it's just the injection library which tells you, oh, the connection succeeded. You will never see the real packets coming over the network for that connection. That's why if something is using raw sockets and stuff which needs little PCAP or similar stuff to snip out the wire to work, these things will not work with Granscaler. They won't work with SOCs or whatever either. For that stuff, you would need to implement IPsec on your system, systems in between the target system. Still, Granscaler works, it's just work as it warns you. This will not work, but still allows the program to run because it might do some local things. Yes?
For the raw sockets, do you forbid them? Like, you look into the socket call and say...
I don't forbid them.
Okay, so...
It's just warned about, because it might do some local stuff where raw sockets are needed, that's why I don't prevent them.
Okay, because if you get used to the tool, you might just put like an NS lookup on your local box or something, and it will do a lookup to a target host, and you don't want it to be initiated from your local host.
For that, as in the slide before, you saw that I hook up into the get host by name call. The get host by name call is first transferred to the last proxy in the chain, resolved there. It was unable to resolve that because it's internal some system. They can resolve www.sun.com, for example. It resolves that on your local system afterwards. See, okay, it failed on that system, I might be able to resolve it and gives you that reply. If you're interested in that, I might put in an extra option which prevents all the local stuff and disables to allowing raw sockets or something like that. If you wish that, I don't do that, no problem. I do everything for you. Not for you guys, just for the good friends of us. We'll bring beer to the party later, right? Okay, and as I say, it's an alpha state, so I'm still experiencing some crashes because right if you close all the scriptures, I think I need to recode it really. So, how would you use such a tool? You run one of the Granscaler proxies on your local system because it's the most easiest way to use it. Otherwise, if you just run it on a target system, there's a firewall in between which would prevent you connecting to some sockets which are important. Then you put Granscaler on as much systems you like in between, so you can have a proxy chain. Then you add the GG, it's just a shell script to make stuff simple for you, and define which tunnels are in between. So first, you've got the IP address of the next tunnel, its port where it's running on, and then a password. This password will, in the next version, use to encrypt the connection. Then, a greater sign, there is a definition for the next proxy in the chain until the final proxy, which is in that example 10.3.3.3. This is the last proxy in the chain which will execute the connect calls or whatever. Not any of the systems between it, they will just transfer the pass data on. And then you just put GG, the small chest in front of the commands you would like telnet, nmap stuff, RPC info, or whatever, and you will have all the results of the target system, even if you can't connect to the telnet port or to the RPC port, some RPC port, whatever. So, how does it work? You remember that picture, I hope? You're running the first transparent instance on your own system. On the web server being set, which you were able to hack, you run the next transparent instance. From there, you were able to hack the internal web server, because you need to connect there, and it was just another hole there. Then you put the next transparent instance. And now, you're just using that final proxy to attack the internal system transparently. So just using nmap, RPC info, whatever, on your local system being executed down there. So for this to be effective, the grand scaling instance must be portable. That's why there is as less intelligent, very little feature support in the grand scalar instance in the daemon, so that it compiles on all platforms. Currently it's verified to compile on Solaris and work on Solaris as well as Linux and will open BSD. But the goal is also to be able to compile and run on Windows with no DLL necessary whatsoever, except the stuff which is standard, of course. Yeah. Also next after that. So this is how it would look like. Also something I make here live on the camp. GG nmap. I just did a port scan for port 100 to 113. Make the output small. And the target system. So you just see it reported one state open, but from that output you don't know how many transparent instances there were in between, because it's not important for you. If you take a look at the script, you will see that. On the last grand scanner instance, it looks like that. So I SSH to another machine. There it informs us that the admin connection is coming in, that the initiation was successful. There is some authentication done already, but easy to spoof. So after I implemented full encryption, there will also be some stuff to prevent man in the middle, replay text, and other stuff. Here it executes a port scan from anywhere, as you can see. So it first tried to connect to port 109, which failed because the port was closed. Here in that line, you can see that port 111 was a success, so the port was open. And finally all others failed. And, well, then I terminated the program. So this is what you see as the output from the last proxy in the instance. So, the future. Secure ID generation and usage, data encryption, well, reverse and command line tunnel connections. So, for example, you just drop it on the box, run it, and it automatically builds a connection back to you or a proxy in that chain. So even if it does not allow you to connect into it, it connects back to you. So home feature. Also put some on command line or an admin GUI, or command line GUI, so to say, a clean, which says, okay, now build that tunnel to that. Proxy support, so HTTP proxy support via the connect call. So if you have an internal server hack and you install a grand scanner, that you have a reverse connection via a proxy. Local stuff, like there's something I implemented but removed for that reason, because it would be insecure in the current model. So which allows you to execute local commands to kill the daemon, to remove the file of the system and other evil stuff. One mask product. You will see what it means when you see it in the next release then. So next release, I'm already working on more stuff to get that stuff implemented, and maybe more things like wishes from special friends. Where to get it? Well, you already saw the web page. It's the first public alpha. I did some small closed beta testing. Many stuff works, some stuff doesn't. Well, just try it out and have fun with it, but please don't do anything illegal, because this is really something nasty. Well, whatever. Okay. Any questions? Yeah, there's some guy. Source, if it will support source routing.
No, I mean, there's a kind of set of thing that works running technicals for your.
It's like source swapping, but if you do source swapping, of course, the file would filter the target course. This enables us to get over that filter definition. It's not doing something like onion routing or whatever. Yeah, so it's not trying to diffuse traffic so nobody can see what was sent to which target. It's not the intent of the tool. If you want something like that, you can install such additional tools which do that for you. But it's not the goal of that tool to implement that really. Yeah, Scott?
I understood that you only have one connection to the raw key, and you multiplex all socket calls into one connection. How do you manage it to keep it synchronized? Can you use one beam on the remote side and one on the client?
Yeah, that's
Or does it work on the technical side? But do you use threads or port children or?
No, it's just one. It's a non-working socket where it reads all the protocol definitions on, puts into a queue if it's a port in a special state, and then it reacts to them. So blah blah blah. Pretty straightforward, really, and no threads are cool. I need to implement threads and stuff or whatever.
Last data, can I identify GG?
No. In the current implementation, it could if it has the right trigger. In the next, it won't because Raspberry will just reply the packet if it encrypted with the right key. Yeah. Only good key, good reply. Bad key, no reply. Then Emmet can't detect that. I mean, it's not the goal of that tool. Okay. Anyone else?
Do you need root access on the remote machine?
Nope. Any user ID is enough if it's allowed to bind to a local port. Any port. You can define it on the command line. You can compile it in, whatever.
So like user.steam, for instance, you have a sock.steam user space where you can bind.
Right. That's really what it is. Without the application, the next week with full encryption, no paper trail whatsoever, except the standard error output, which you in next week can also disable, of course.
Okay, thanks.
Any more questions? Because I'm speaking here.
What's the problem with PMAP? You mentioned that you were able to use applications that use a little PCAP. Why not? Why can't you just intercept the library calls and call them to the remote side?
That might be possible, but in that stage of development, that's a goal which is far in the future. But in general, you are right.
Okay, thanks.
If it's using the PCAP or something, it's possible. Well, if you want, you can just join the project. Any help welcome, if it's good code. Okay, no more questions? Well, thank you for coming here. I'm wet already. I hope you are as well. Goodbye.